Here's a problem from section 1.2 linear modeling, a mixing problem. So this is a classic mixing problem. At the end I'll talk about other kinds of mixing problems. Wilmot has two solutions. One is 40% hydrochloric acid, which is abbreviated HCl, and the other is 90% HCl. He needs a 100 milliliter solution that is 50% HCl. How can he combine the two solutions he has to get it? Okay, so the classic problem-solving approach, you can use any problem-solving approach you want, by the way, as long as you test to make sure your answer makes sense. Okay, our problem-solving strategy is find variables, write an equation, find the solution, write the answer, and then check for reality. Okay, so what are we solving for? What do we really want? Well, we're trying to find how much of these two solutions he's using. So just because in math we usually do it this way, let's call X the amount of solution 1. That's the 40% solution. And Y the amount of solution 2. That's the 90% solution. Okay? Now, since I've got sort of two variables I'm looking for, what I need to do is I need to sort of think about two equations that might relate this. Now, there's usually a really simple equation that involves the total amount. Okay? Since the total amount is 100 milliliters, you might think, okay, well, if you had X amount in solution 1, Y plus X is supposed to equal 100. That means Y equals 100 minus X. In fact, some people don't even bother to write Y, they just write 100 minus X right there. So whatever amount you put in solution 1, the rest is solution 2, right? That'll make you add up to 100 milliliters. Okay, now the main equation is we need a certain amount of acid, okay? And the way mixing problems usually work is you should think of it this way. You should think of acid from the first plus acid from the second better equal total acid. Every mixing problem I know of works like this. If we're talking about interest, how much interest did you get from the first investment? How much interest did you get from the second? Better come to the total, right? So, once you have this framework, life gets wonderfully simple. If I had 10 milliliters of a 40% liquid, I could tell you how much acid I got. I'd multiply 10 times 40% times 0.4. Since I don't know how much, I'll just write 40% or 0.4 times X. That's how much acid I get from this first solution. How much acid do I get from the second solution? Well, you could write Y, then substitute in 100 minus X. I'll just write 100 minus X to start with. That's how much solution. I know it's 90% acid, so that's how much acid I get from the second solution. Now, how much total acid do I get? Now, the problem doesn't actually tell me this, but notice it's 100 milliliters, 50% HCl. That means, you could write it out, 0.5 times 100, that's 50, right? So here's my problem. Usually I wouldn't write that, but I think that every single time. So let's imagine we didn't write that, just to save a little board space, and because typically I wouldn't actually write that, but I would think it. Okay, so I've got 0.4x. What do I have to do here? Well, I have to distribute. So 0.9 times 100 is 90 minus 0.9 times x. 0.5 times 100 is 50. I'm going to gather like terms. Let me subtract 90 to the other side. Let me take 0.4 minus 0.9x. It'll get me a certain number of x's. That's negative 0.5 x's. Okay, so I've got two negatives. Often what we'll do is we'll just multiply that times negative 1. Now we need to divide by 0.5. You could write divided by 0.5. Also, you could say, hey, how do you divide by 0.5? That's the same as multiplying both sides by 2, right? Well, that makes life pretty easy for us. 2 times a half is 1, so we get x equals 80. Well, what was x? X was the amount of solution 1. So how much of solution 2 do I have? 100 minus 80. So y is 20. I could write he needs 80 milliliters of the first and 20 milliliters of the second. Please don't stop there, okay? Whether it's just a mental check, is that reasonable? Does it add to 100? Does this seem reasonable? That's great. That's sufficient. Or if you have time and you really want to ace an exam, you need to be careful. And you can check this. You can say, okay, let's see. If I had 80 milliliters of a 40% liquid and I had 20 milliliters of a 90% liquid, what would I have? Well, here, can you see that you would have, let's see, if we multiply that out, we get 320, but then one place goes to the right of the decimal point. And here, I multiplied out 180. Oops, that's a plus. That's 18, so 32 plus 18 is indeed 50. And 50, of course, is half of the 100 milliliters. So I'm perfectly right, and life is great.